Welcome back to the deep dive. Today we are strictly on a mission.
Yes, we are. A very specific one.
Yeah, if you're listening to this right now, chances are you've got a very specific goal in mind. You're staring down the barrel of the CT-GenAI exam.
Certified tester in generative AI. It is, it's really the shiny new badge that everyone in the QA world is talking about lately.
It's huge right now.
It is huge. And honestly, it's not just about, getting a badge for your LinkedIn profile.
Yeah.
This exam is essentially a roadmap for how our entire industry is changing.
Yeah.
But let's be honest, the syllabus is dense.
Yeah.
And just taking the exam is stress-inducing.
Oh, totally. I've looked at the sample questions, and they are tricky. They really are. So we're not just going to talk about AI concepts broadly today.
Right.
We are going to simulate a study hall for you. We've pulled 10 specific high-probability practice questions that cover the core domains.
That's fundamentals, prompting, risks, and strategy.
Exactly. We are going to, we're going to hack this test.
Well, I wouldn't necessarily say hack, but we are certainly going to deconstruct the logic.
Fair enough.
The goal isn't just to memorize that, C is the answer. It is to understand why the right answer is right. And perhaps more importantly, why the wrong answers are distractors.
Because on the real day, they might change the wording.
Exactly. They change the wording, but they will not change the logic.
Makes sense. Okay, before we jump into the very first question, let's quickly set the stage with the rules of engagement.
Good idea.
If you walk into the testing center tomorrow, what are the actual logistics you're looking at?
Okay, strictly looking at the exam format, you are facing 40 multiple choice questions.
40, okay.
And each question has a single correct response. You have exactly 60 minutes to complete it.
Wow, 60 minutes for 40 questions. That is a tight turnaround. That's what, 90 seconds a question?
It is tight. You really have to move fast.
Yeah.
However, if you are a non-native speaker taking the exam in English, you do get an extra 15 minutes.
Well, that's good to know.
Yeah, bringing it to 75 minutes total.
And the magic number. What do we need to see on that final screen to breathe a sigh of relief?
The passing score is 65%. Mathematically, that means you need to get at least 26 out of the 40 questions correct.
Okay.
You can actually get 14 completely wrong and still walk away with the certificate.
All right, 26 correct answers. That feels doable. Let's get you those points.
Let's do it.
We're going to start with segment 1, the brain of the AI. This covers the technical constraints because you have to know the machine to test the machine, right?
Right. This domain tests if you actually understand the limits and the learning methods of the model.
Which is crucial.
It is. This is where a lot of manual testers trip up because it requires understanding the architecture, not just the user interface.
Okay, so let's look at question 1. Here's the scenario. You are in the middle of a long testing session.
Yeah.
You've pasted in requirements, you've iterated on test cases, and suddenly the AI seems to lobotomize itself.
It happens all the time.
Yeah, it forgets the instructions you gave it just 10 minutes ago. So the exam asks, what describes the limitation on how much history an AI can remember during a single conversation session?
This is a classic fundamental question right here. It touches on the most common frustration users have.
So here are your options. Is it A, storage capacity, B, processor speed, C, context window size, or D, network bandwidth?
What's your gut reaction?
Well, if I'm just guessing, storage sounds right because, it ran out of space to store my words.
And that is exactly why storage is the main distractor. But in computer science terms, storage usually refers to the hard drive, the long-term memory on the server.
Right.
That isn't what's happening here. The correct answer is C, context window size.
Let's unpack that. Why context window?
Think of the context window as the AI's working memory, or its attention span. It is measured in tokens.
Tokens, okay.
It defines exactly how much information, so that's input plus output, the model can hold in its immediate view.
So it's kind of like a sliding window?
Precisely. As you add more text, the window slides forward. Once the conversation exceeds that token limit, the model has to truncate earlier content.
It literally cuts off the beginning of the chat.
Yes, to make room for new words. That is why it forgets the instructions you gave it 10 minutes ago. It affects continuity and accuracy.
So it's not that the internet is slow, which would be bandwidth.
Right.
Or that the hard drive is full, which is storage. It's that the short-term attention span is full.
Exactly. So if you see memory limit or forgetting earlier conversation on the exam, find the option that says context window.
Got it. Okay, let's move to question 2. This one is about how these models actually learn new tricks.
Okay.
The scenario asks, which process involves training a base AI model further on a specific set of testing data to improve its domain accuracy?
The keywords there are training further and specific set of data.
Right, so your options are A, prompting, B, tokenizing, C, scaling, D, fine-tuning. Now, I feel like a lot of people might guess prompting.
Oh, absolutely.
Because that's what we do every day to make the AI smarter.
That is the trap. The correct answer is D, fine-tuning.
What is the difference, then? Why isn't it prompting? Like, if I paste my company's coding guidelines into the chat, aren't I teaching it?
You are guiding it for that session, but you aren't changing the neural network.
Okay.
Prompting is ephemeral. It disappears completely when you close the window. Fine-tuning is different.
How so?
It is an actual training process. You are taking a pre-trained base model and feeding it a data set of domain-specific information.
Like proprietary coding standards.
Exactly. Or medical terminology.
So you are actually altering the weights inside the model.
Yes. You are adapting the model to a specialized area. The result is higher accuracy for that specific domain because it has effectively studied that material.
Rather than just being told about it in a prompt.
Right.
So prompting is like giving a student a cheat sheet for the test. Fine-tuning is sending the student to medical school for 4 years.
That is a perfect analogy. Fine-tuning creates a permanent change in how the model behaves.
Okay, that's a very clear distinction. Fine-tuning changes the model, prompting just guides it.
Exactly.
Speaking of prompting, let's move to segment 2. This is all about speaking the language of the AI.
This is a huge part of the exam. Prompt engineering isn't just chatting, it's a real strategic skill.
Let's look at question 4 first, actually, because it sets a baseline.
Sure.
The scenario is, a tester asks a direct question to the AI without providing any examples or context, just a raw question like, write a test case for a login button.
Right.
The exam asks, which strategy is this?
Okay, let's look at the menu.
Options are A, zero-shot prompting, B, multi-shot prompting, C, chain prompting, D, recursive prompting.
The answer is right in the name. It is A, zero-shot prompting.
Because you gave it 0 examples.
Exactly. You are relying entirely on the model's pre-trained knowledge. You aren't showing it what to do, you're just asking.
Is that considered a bad practice?
Not necessarily. It is efficient, it is fast.
Right.
But as the explanation in our source notes, it allows for less tailored results.
I see.
If you need a very specific output format, like, say, a Gherkin syntax test case, zero-shot is risky because the AI might just give you a generic paragraph of text.
But if you just need a quick answer, it's the standard approach.
Yes.
Okay, so zero-shot is the default setting. Now let's look at how to improve that with question 3.
Let's do it.
The scenario is you are about to ask for a testing strategy, but before you do, you tell the AI you are a senior test manager.
I love this technique, the persona pattern.
So the question asks, assigning a persona is an example of what? Options are A, few-shot prompting, B, feedback looping, C, iterative design, D, role-based prompting.
This one should be a slam dunk if you just look at the terminology. The answer is D, role-based prompting.
Why does this work so well, though? You are a senior test manager. It kind of feels like we're playing pretend. Why does the math care about that?
It cares because of probability. The model simply predicts the next word based on the context you provide.
Okay.
When you assign a persona, you are guiding the AI's tone, its perspective, and its level of expertise.
So it stacks sounding like a generic encyclopedia.
Right. Think about it this way. If you ask for a test strategy as a junior developer, the AI might prioritize code coverage and unit tests.
Because that's what a junior dev focuses on.
Exactly. But if you ask as a senior test manager, the vectors shift. It starts talking about risk analysis, resource planning, and release schedules.
It aligns the response with the patterns associated with that role in its training data.
Yes. It's about context setting. You're basically narrowing the search space for the answer.
I really like that. Narrows the search space. Okay, let's shift gears. We've covered the brain and the language. Now we need to talk about the scary stuff.
Oh, yes.
Segment 3, the danger zones.
Risks. This is a major component of the CT-GenAI syllabus. You really have to know what can go wrong or you're dangerous to your organization.
Question 5 addresses a huge one, privacy. The question asks, what is the most effective method to ensure data privacy when using public AI models for testing?
Keyword there is public, like the free version of ChatGPT or Claude.
Right. The options here have some pretty funny distractors. A, sharing login credentials. B, removing all personal identity details. C, using only capital letters. D, printing the prompts first.
Please, for the love of cybersecurity, do not think that using capital letters protects your privacy.
Or printing them. I printed it so the internet can't see it.
That is hilarious. The correct answer, obviously, is B, removing all personal identity details.
This seems like common sense, but why is it emphasized so much in the exam?
Because compliance is non-negotiable. If you're using a public model, anything you type in can potentially be used to train future versions of that model.
So if I paste a real customer's name or a real credit card number or even a unique internal ID,
you have potentially exposed confidential information to the world. Imagine a competitor asking the AI about your company 6 months from now, and it just spits out the data you pasted in today.
that is the nightmare scenario right there.
It really is.
So the rule is anonymization?
Yes. You must strip PII, personally identifiable information, before hitting enter. Period. That is the only way to comply with data protection regulations like GDPR or your own internal security policies.
Okay, so protect the people. Now let's protect the content. Question 6. This deals with the legal side.
Okay.
The scenario is you are using AI to generate proprietary test assets, maybe code or test cases. What is the significant legal concern here?
This is the black box problem.
Options are A, internet service availability, B, intellectual property infringement, C, screen resolution issues, D, keyboard layout compatibility.
Again, distractors like screen resolution are just noise to see if you're awake.
Clearly.
The answer is B, intellectual property infringement.
Explain this one for me. If the AI wrote the code for me, don't I own it? Or rather, how do I infringe on someone else?
Because the AI didn't write it from scratch. It learned it from somewhere.
Right.
The risk is that the output might unintentionally reproduce copyrighted or protected material that was in its training data.
So if the AI was trained on open source code that has a restrictive license?
Yes. And it spits that exact code out for your commercial product, you could be sued.
Wow.
That is the legal concern. The AI doesn't know about copyright. It just knows patterns.
It's just doing math.
Exactly. Commercial environments need to be very, very careful about ownership and copyright violation when using generated assets.
That is a scary thought. It's almost like using a stock photo without checking the license.
Precisely. You wouldn't do it.
Okay, let's move away from the doom and gloom and talk about the future. Segment 4. Agents and operations.
This is where we move beyond simple chatbots and into automated work. This is the cutting edge.
Awesome. Question 7 asks about AI agents. Specifically, what is the main benefit of using an AI agent for autonomous exploratory testing?
We really need to distinguish agent from chatbot here. That's the key.
Options. A, executing complex task sequences. B, reducing electricity usage. C, replacing all manual testers. D, creating physical hardware models.
The answer is A, executing complex task sequences.
Why is that the defining feature of an agent?
The chatbot answers questions. You talk, it talks.
Right.
An agent actually does things. It is designed to reason, plan, and interact with tools.
Okay.
In exploratory testing, an agent can simulate a user clicking through a workflow, reacting to what happens on screen, and actually deciding the next step.
It's the autonomy, right? It doesn't need me to prompt it for every single click.
Exactly. It can execute a multi-step workflow without constant human intervention.
That's wild.
It sees a login screen, it inputs text, it sees an error, it retries. That is the power of the agent.
Now, if we have all these agents and models running, we clearly need to manage them. That brings us to question 8, and a term you see a lot, LLMOps.
Large language model operations.
The question asks, what is the primary focus of LLMOps in a testing org? One of the distractors here is managing office furniture, which I appreciate.
We can safely rule that out.
The correct answer is C, lifecycle management of AI models.
Right. Think of DevOps, but for AI.
Okay.
LLMOps isn't just about turning the server on. It covers deployment, monitoring, version control, and governance.
Governance seems key here. Why do we need to manage the lifecycle, though? Doesn't the model just stay the same once it's deployed?
No, actually, models drift.
Drift.
Yes. Their performance can degrade over time, or the data they interact with changes. LLMOps ensures the system remains reliable, secure, and compliant over time.
So it's not a set it and forget it thing?
Not at all. It is the operational backbone that keeps the AI running correctly in a corporate environment.
Okay, we are in the home stretch here. Segment 5, strategy and governance. This is the big picture stuff.
This is for the managers and the strategists listening, or really anyone who wants to lead an AI initiative.
Question 9. Your organization wants to adopt GenAI. What is the priority step? What do you do first?
Do not say buy the tool, please.
That's usually option A, buying the most expensive model. Option B, deleting all manual test cases. C. Hiring only AI researchers. D. Identifying suitable use cases.
Your answer is D, identifying suitable use cases.
Why is that the priority? Why not just get the tech and figure it out later?
That is a guaranteed recipe for wasted budget. You have to identify where the AI adds value before you spend the money.
High-value use cases.
Exactly.
Yeah.
Does it solve a real business need? Does it deliver measurable benefits?
Right.
You don't want a solution looking for a problem. You identify the bottleneck in your testing process first. Then you apply the AI to fix it.
Makes total sense. Don't buy a Ferrari to go grocery shopping.
Right, exactly.
And finally, question 10. This is perhaps the most critical concept in the entire field. The question asks, what does the concept of human-in-the-loop signify?
HITL.
Yeah.
You will see this acronym everywhere. You cannot pass this exam without knowing this concept inside and out.
Options are A. Human training of basic code. B. Human replacement of the AI. C. Human review of AI outputs. D. Human-only manual testing.
The correct answer is C, human review of AI outputs.
This is the safety net.
It is the golden rule of GenAI in testing. The AI is not perfect.
Definitely not.
It is probabilistic. It guesses. It hallucinates. It makes mistakes. Human in the loop means a human is actively validating and approving the results.
So it combines the speed of automation with human judgment.
Correct. It ensures quality control, reduces risk, and maintains accountability.
If the AI messes up, the human is there to catch it before it goes into production.
Exactly.
Thanks for listening to The Deep Dive. We'll catch you next time.